Hello, everyone, and welcome to Integration Down Under July 2021. Wonderful night. We're going back into lockdown in Melbourne. Sydney's in lockdown, or at least partial lockdown, if you call it that. And then we've got lots of fun going on. So let's go on with our slides. So let's see, we've got, come on, whoops. Our organizers, so Martin, Dan, who's on the call tonight, Wagner, Renee, and myself in Melbourne. And tonight we have Bec Lyons, and Bec has joined the product group not long ago and is shortly going to be making her way from Melbourne to Redmond to be on the team over there. Known Bec for several years working through Microsoft, and it's good. And so she's going to be talking about the Logic Apps DevOps experience. So she's been working a lot on that. And so it's going to be a really good chat tonight, because DevOps has always been one thing that was a bit lacking to start with in the Logic Apps. So it'll be much better now. So let me unshare my screen and get Bec to share her screen.
No worries. All sharing okay?
Yep, I'm just bringing it up now. So, okay, here we go. And awesome. I'm gonna disappear off of the stream and leave it to you.
Great. Well, thanks for having me on Integration Down Under. I'm going to be talking all about DevOps for Logic Apps standard specifically. I'm going to be going through a couple of things, and I hope to leave you with a couple of key nuggets of gold. So I'll kick off with what's new in Logic Apps, mainly the components that really pertain to DevOps specifically. I'll then do a quick comparison of what consumption and standard DevOps looks like for Logic Apps. A lot of us might be used to how we develop and deploy our ARM template-based Logic Apps in consumption. Standards is a little bit differently, so I'll set the scene with talking through the differences there. And then I'll go through a couple of key concepts. These are typically the things I get asked the most, such as, how does the new structure of standard Logic Apps work? It's a little bit different. The architecture looks a little bit different to consumption. So I'll go through what that looks like in terms of the application package and the infrastructure that it will run on. And then I'll talk through the differences between built-in API connections, mainly from a DevOps point of view, because that is a point that comes up quite a bit. And then I'll talk through the differences between the parameters experience for Logic Apps and app settings, because app settings is now something you can take advantage of in the standard SKU. And I'll talk about when to use what solution and the scenarios that will be relevant for those. And then I've got a demo, and due to popular demand, all my demos are usually in GitHub, but I have created a demo in Azure Devops. Azure Devops is, definitely one of our core services, so it is definitely something that we still support and have a lot of great tools to develop and deploy your Logic Apps with. Then at the end, I'll talk about roadmap, what's coming, and we can go into questions and discussion at the end. Okay, so I'm going to breeze through this because there's a lot that's new over the last couple of months, particularly June with build and integrate and all the goodness in between. So we did go GA with Logic Apps Standard last month in June. So you are now able to use standard Logic Apps in production as any other product that would run on Azure. As part of our build announcement, we also announced the ability to run Logic Apps on Arc-enabled Kubernetes clusters. So being able to run the full managed Logic Apps service with run history and all that goodness on infrastructure you own and control, whether that be on Azure or off. That is currently in public preview at the moment. And then to support that particular way of running Logic Apps, i.e. disconnected from Azure, we've also released our storage alternative, which is SQL Server, so that you can host your SQL Server as your storage backend right alongside your Logic App, wherever that might be. It doesn't have to be on Azure anymore. And then we introduced parameter support for standard Logic Apps. Now, this was mainly the backend support for this, and we have a roadmap item which is coming very soon for the new UI for parameters. So I'll be showcasing that in the demo today. There's a lot of goodness coming, so looking forward to your feedback on that. We also introduced a new CLI, which is currently in preview, which we have documented in our DevOps documentation. I've listed all the new docs that are available, so if you haven't had a look in the Logic Apps documentation over the last 2 months, please do. There's a whole bunch of goodness that you can sink your teeth into. And we also have a bunch of updated samples since we went generally available. So we have a sample, which I'll be running through today for Azure Devops, and we also have a sample for GitHub as well. If there are any other samples, any other docs, any other features that you are looking forward to or you have an interest in, then we have a survey that you can go ahead and fill in, aka.ms/logicappsdevops. We would love to hear your feedback. I do check it regularly, and I look forward to hearing your thoughts on what you think the DevOps experience is like. Oh, we also have a end-to-end Azure integration services sample for a digital integration hub, which is also available if you want to have a play around with that. So into the content and comparing the DevOps models from the consumption world to the standard world. So the first point of difference is that workflows for consumption are built in the designer against a live Azure resource. So you can build in Visual Studio, but that is actually executing and running against something that is hosted and being built on Azure. In standard, you can actually build and run your Logic Apps completely off Azure locally in VS Code, as well as taking advantage of the Azure portal for development if you so choose, and the designer there. So you do have the flexibility to run offline. Under the hood, it's kind of all the same engine, same way of working. It is configuration as code. That is the benefit of the Logic App service, where you get the designer to rapidly build your workflows, and then behind the scenes, it's just a bunch of configuration files. So applying DevOps to that right now is a lot more generic with the new standard runtime. With consumption, those pieces of configuration, including the workflow, the connections, the parameters, everything lived in the ARM template, which meant that as a Logic App developer, I needed to be infrastructure and application aware. In standard, this all kind of lives in a nice little application package. If you've used Azure Functions before, or if you've deployed any type of application, it kind of works like that, where you have your integration or your Logic App project, which has all your workflows in it, which can package and be deployed separately from the infrastructure that runs it. The infrastructure as code templates are deployed with the workflow notes config. The Logic Apps can be zipped separately and containerized separately on top of those infrastructure deployments, as I just mentioned. Another piece that is interesting to note is that parameters are defined at deployment time, which means that, and I'll go through an example, if you have a key vault setting that you call in deployment time and that changes down the line, you have to go ahead and redeploy that pipeline in order to pull that connection or that whatever that string is and redeploy it. It doesn't actually fetch at runtime. With the new standard SKU, we have support for app settings, which actually call out at runtime, which means you can actually dynamically update those strings and also dynamically call out to key vault, and it will just simply pull the latest key from that key vault. So that's pretty much what it looks like. Consumption is everything in an ARM template. Standard is more similar to a traditional application, where you have your application code, in this case it's configuration code, and your infrastructure templates, which are built, managed, and deployed usually at a separate cadence. But also you do have the ability to deploy them together if you so choose to. So let's talk about the new structure. If you haven't already had a look into the standard Logic Apps, this is what that structure looks like. A couple of key things to call out here. Those maps and schemas, rather than being held in an integration account, you can host them and run them locally within that Logic Apps package itself. So these actually get packaged up into the build artifact and will move along with that as it goes through different environments, rather than you having to have different integration accounts for different solutions. If you are using things like partner agreements and things like that, you'll still need an integration account. For your workflows, the structure is a little bit different. So rather than having a one-to-one mapping of a Logic App resource to workflow, you now have a one-to-many type view. So one Logic App can house many workflows, and you can have them all within the one project and developing them locally, packaging them up into one particular application, and then deploying it to one Logic App. A little bit further below, you've got connections.json, which is taking all that connection metadata and putting it into a separate file. Something that's not showcased here, which I'll go through in a little bit, is a separate parameters.json file, which you can actually reference different parameters from your workflows and your connections.json so that you can define all of this stuff once. And then the only thing that will change between environments are those parameter files as well as those app settings. So let's another look at what it looks like. You've got your workflows, maps and schemas, your parameter files, which feed in those different environment variables to the workflows and connections.json. And those parameter files can actually reference your app settings. So it makes them really dynamic as you go along your DevOps pipelines. So let's have a look at how that actually runs on the Logic App resource itself. So essentially everything on the left-hand side, that gets zipped up into a nice build artifact package, which then gets deployed and run on a Logic App resource on Azure. To run this Logic App resource, that needs some sort of compute under the hood, which is managed on a workflow standard plan. Workflow standard plan, pardon me, is very similar. If you've ever used the Functions Premium plan, you can set the auto scale rules up and down to give you really good control about how you scale, and you can bump it up a tier if you need more compute. This uses a storage account or alternatively a SQL server behind the scenes to store all of your execution state and run history. Your API connections, those are the 400 different connections that you know and love today. Those don't change. They continue to run on API connection resources on Azure, and they will point to their service or whatever you're connecting to. The only thing that does change between standard and consumption is how the Logic App itself authenticates against those API connections. So in the world of standard, pardon me, glad I had some water here. So in the world of standard, because we don't know where your Logic App will run, it could run on Azure, it could run in a container, it could run on an Arc-enabled Kubernetes cluster on another cloud provider, or on a Kubernetes cluster running on my local laptop. Because of this, it doesn't inherently run on Azure, so the traditional ways that we would authenticate the Logic App infrastructure to the API connections has changed. So what we do is we attach a managed identity to that Logic App, and then that managed identity needs the right permissions to access the API connection, just to make sure that it's all trusted under the hood and all good. So I'll talk through how you can configure that in your ARM templates and automate all of the setting up of every single thing that you see here in one seamless and streamlined pipeline. So what is the result of all that? The result is we get true separation of concern, whereby our developer or integration specialist can purely develop their Logic Apps and not have to worry about the infrastructure. That can go through its separate pipeline, or because it's just configuration files, all you really need to do is zip it up into a zip package and then deploy it to the Logic App resource on the other side, or you can containerize it and deploy it to your container infrastructure. Your operations specialist, they can then handle, or whoever in your organization handles all the infrastructure stuff, they can handle the networking and the configuration and all the APIs and the connections and all that goodness, which can be all automated through an infrastructure as code pipeline and deployed to your resource groups. These can be deployed in a range of different ways, a range of different patterns. I'm not going to go through all the patterns today. I have a very simplified DevOps pipeline to kind of help get started. But what you do with these constructs is absolutely up to you. So let's talk about the built-in versus Azure connections. So with the standard SKU, we have two types of connections, built-in and not standard there, the Azure connections. What the built-in connections are is they're a bunch of different connections that run locally within the Logic Apps process itself. I'll just so we can see it there. So these are hosted and run within the Logic Apps process, and your Azure API connections, the 400 plus ones that you're familiar with today, they run as a separate Azure resource. The benefit of built-in is that they can run disconnected from Azure. They run locally inside the Logic App package itself. So they run in the actual resource of the Logic App, whereas the Azure Connections run on as a separate Azure resource itself. Now, we have currently 17 built-in connections, and these are typically the most commonly used ones. And we have all the 400 plus rich ecosystem of the API connections. Usually the API connections are things like SaaS services, so they need to be internet connected anyway. But we are growing that built-in connector ecosystem, so you do have the ability to run those built-in connectors locally. They're also really nice to DevOps, and I'll showcase that in a bit. Another core question I get asked a lot is when to use parameters or when to use app settings, because we have two types of ways of parameterizing your logic apps in this standard SKU. Parameters are, let's just build this out. Parameters run locally in the logic apps process itself, and it's kind of packaged up into that application zip file. So it kind of, whenever you do a zip of that logic app application, it'll run within that, and you can do things to completely swap out those parameter files. If you're familiar with consumption-based logic apps, then the actual UI and experience for parameters will be quite familiar for you. If you are familiar more with functions and web apps, then the app settings side might be familiar to you. These actually run on the Logic Apps service, not inside the application package. So they run externally to the Logic App code, which means that they can be redefined at runtime, and they can be dynamically redeployed and reconfigured. They can also call out to Key Vault directly, and they can be updated either via ARM or via CLI. The one deterrent of app settings, which is why we have both parameters and app settings, is that they can only hold simple serialized strings, and there are some limits of how many app settings that you can have. So this is where you can use parameters. Parameters can both call app settings if you need something secure in Key Vault, or you need something updated in your infrastructure pipeline, but they can hold complex objects, and they can be referenced from the token picker with the UI that's coming soon. And the designer can actually resolve those parameters when you use them for local development. So this is essentially the difference between parameters and app settings and where they sit. So as I mentioned, the parameters run inside the application package itself. They can be referenced from your workflows. Excuse me. They can be referenced from your workflows. They can be referenced from connections.json. And they can also reference an app setting. So if you have a secure string, such as a service bus connection string that you use for a connection, pardon me, you can reference an app setting, which might be configured during your infrastructure as code pipeline. So it makes it really dynamic in terms of where you host things and how they work. The recommendation of the scenario of when to use what, since parameters will be able to be easily configured in token picker and not token, but in the designer, then it makes sense to use them when you're designing your workflows, and your app settings are really easy to be configured in your infrastructure as code pipelines. So anything that is infrastructure specific or does dynamically change when you deploy ARM templates, it makes sense to define them there. And I'll go through those examples in the demo. Okay, so I've kind of gone through a couple of different core concepts, the differences between DevOps for standard, the difference between DevOps for consumption, when to use parameters and app settings, and the difference between built-in and Azure Connections. So now I'm going to jump into a demo that goes through this end-to-end. I'm going to start with a simple scenario and create a new built-in connection. As I mentioned, they are simpler to run. And I'm also going to deploy a Azure connection to show the differences between deploying those. I'm going to use both parameters and app settings and talk through when to use those. And I'll be using Azure Devops as my platform of choice.
Bec, we do have a question out there about, can't Logic Apps in consumption be built in VS Code or Visual Studio?
Correct. You can build them in Visual Studio, but you run them against a live Azure resource.
And then the difference too is I think that in Visual Studio Code, the consumption ones, you can't actually, the designer's not there, is it?
I've always used it in Visual Studio, so I can check with that at the end.
Yeah, because that's one of the things I've been using VS Code mostly lately, even with the consumption ones, and they're in the ARM template. So that ARM template, I don't think so.
Got it.
Okay.
Any other questions out there?
No, that was the only one.
Cool, thanks. So this is a architecture of what we're going to be going through in the demo. So I'm going to start with local development. I'm going to build out my workflows as we go along. And then I'm going to push up my code changes to my, in this case, it's Azure Devops. I'm going to run some pipelines. I've got 3 pipelines I'm going to go through today. A typical build pipeline, which will zip up the application package. I've got a release pipeline, which will actually deploy that to a Logic app. And I have an infrastructure as code pipeline, which will actually deploy all the infrastructure pieces that I need. So I'll go through these one by one, bit by bit, and we can build it up over time. So I'm going to flick over to my environment, and here we go. So here we have my my sample here. I'm just going to make everything small. Where I got this from, if I just... So I got the baseline for this template from the Azure Logic Apps GitHub repo. We have a GitHub sample, which you can use, or an Azure Devops sample, and you can copy in the baseline for this particular demo. What we have included in here are sample pipelines, sample ARM templates, and sample workflows, so that you can build off of this and make this as complex or as modular as you need it to be. This is just a good place to get started so that you don't have to reinvent the wheel. So what I have in my local project here, I have all my pipelines defined in YAML, which will eventually run on Azure Devops. I'll go through those in a little bit. I also happen to have my ARM templates here. You don't have to have this in the same project. You can have these separately. I just have it here just for demo purposes. And then I have my Logic Apps files here. So if you open VS Code and you say, I'd like a new Logic app, please, it'll configure something that looks like this. So as you can see, this is the structure that I was going through before. I have 2 workflows here, one called Event Trigger and one called Event Processor. I've also got some parameters that I've pre-configured for time purposes here. So I have broken this down into 2 separate workflows. This is one of my favorite patterns to use. It's where you have a trigger workflow, which calls a child logic app, and then all of your business logic is within that child logic app. So in this case, I have an event trigger. Right now, it's pretty generic. It's just a reoccurrence. It's going to kick this off every 15 seconds. It's then going to invoke my child logic app, which in this case is an event processor. And then I'm going to build my business logic up from the ground up. Now, the reason this is a cool pattern, particularly in standard, if you were to do this in consumption, every time you call a child logic app, it makes a call to a separate service. It's another Azure resource, so somewhere different sitting in the data center. When you do this in standard, because this is all packaged and run together, it's actually a local networking call just to my neighboring file, essentially. So it's a lot faster and more performant. So the patterns that we can implement are a lot more, they're a lot more easier to implement, and the latency implications of having multiple different broken out logic apps are a lot less in standard than they are in consumption. So just a cool pattern to take into consideration. You don't have to do this. I just like to do it. It's nice for testing. If you're doing any type of unit testing, it means that if you have something like Event Grid, that's typically harder to test. You can break out the Event Grid trigger and then test your business logic with the HTTP request here. So I'm going to go build a new action. So in this case, for my business logic, every time my trigger runs, I want to go do something. In this case, I want to go put a message onto a service bus. So let's go ahead and add a new action. As you can see, I've got those 2 different types of connections. I've got my built-in ones and I've got my Azure ones. For the first part of the demo, I'm just going to use a built-in connection. So I'm going to connect to my service bus connection. So in this case, whenever something happens, whenever I get triggered, I want to send a message to my service bus. So I'm going to go ahead and configure that all from scratch here. I'm just going to paste this in for timing's sake. All right, so I'm going to call this connection service bus, and I'm going to paste in that connection string. There we go. The name of my topic is accessories queue. And I'm going to add in a bit of content, which in this case, I will put as hello world. There we go, pretty simple. I'm going to go ahead and save that. But something to consider, and especially as you're building your workflows, is what happens if this changes between environments? And it's always good to think about how we can parameterize upfront rather than doing it as a last thing that we have to think about. So in this case, the name of my queue would typically change between environments. It might be accessories queue or dev accessories queue or prod accessories queue as an example. And I don't want to have to go ahead and manipulate my workflow.json after the fact. So this is where I can use the new parameters experience. Now, this is something that isn't launched live yet. So this is a preview version of it, but this gives you an idea of what it's going to look like very soon. So in this case, I'm going to go and copy that particular bit of text out. I'm going to create a new parameter. So I'm going to open up the new parameter file, parameter blade, create a new parameter here. If you've used this in consumption, this will be a very similar experience. I'm going to give this a name. I'm going to call it service bus queue. I'm going to give it a type of string and then paste in that value. So this is what it will be running locally. Then I'm going to come back and I'm going to now see that this is available for me to use in Token Picker. And now I'm going to input that new parameter in there. And so I can now actually start to change my parameter files and change those values as I go between different environments, which means that this template I write once and it doesn't change between environments. So now I'm going to save that. Before I go and think about pushing out my code, I'm just going to come into my parameters.json. As you can see, that new parameter has now automatically saved in here. And I just want to make sure that I have multiple different parameter files. So if I do have multiple environments, I can save it or configure it for those different environments. Now, where you house those different parameter files is completely up to you. I've seen a lot of folks actually have their parameter files stored within their DevOps platform itself. You don't have to have it hosted in the application package itself. There's a bunch of different ways that you can update this.
What if you took the approach like with most of the stuff that I've done recently, where the queue name was the same, but the connection string was different?
Correct.
How easy is it going to be able to modify that connection?
Yes. So this is where the kind of parameters versus app settings comes into play. So in that instance, I'm developing in the designer, and it's really easy for me to create a parameter on the fly, as you just saw. Behind the scenes, when I hit save, this generated a connections.json file for me and automatically parameterized out into an app setting my service bus connection string. So this is actually hosted.
Is that new that it automatically generated the app setting?
For built-in actions, no, but it is something that we are looking to implement for managed connections.
Oh, okay, fair enough.
Because this is really nice.
Yeah, I had a lot of questions early on with the standard of how to modify this connections.json across environments.
Yeah.
So yeah, there is a tool in DevOps that will let you crack the zip file open and modify the JSON files. So, okay.
Yeah. Yeah, I mean, you could do that, but it's not ideal. So we are trying to build in ways that we automatically parameterize things for you. So this is for built-in connections. This is what the experience will be like. And once I deploy this, I'll showcase what it looks like with a managed connection. and I'll talk through the differences in how you can parameterize that.
Okay, thanks.
So essentially with this app setting, what this does, this automatically creates one in your local settings file. So as you can see, well, I should have blotted that out. Let's just scroll down. I've got my service bus connection string. So that's all well and good. Now, if I was, just doing a POC, I would typically come into my Azure extension and right-click deploy. When I right-click deploy, I have the option to propagate all of my local settings into that Logic app. But when I'm doing this to a DevOps pipeline, I don't typically have those automations already set up. So when I have a new local setting that I'm defining in my connections.json file or my workflows.json file, and it's calling an app setting, I need to make sure that in my infrastructure as code pipelines, or in any type of script or via the CLI, that I'm dynamically updating my Logic app resource so that it has those app settings available so that when I deploy this out onto that service, it can get its values that it needs for that environment. Now, there's a bunch of different ways you can do this. If you happen, like me, to kind of be both ARM and Logic app fans, then you can do this right here in your ARM templates. I happen to have it in my same project. Or you can script it out via CLI. There's a bunch of different ways you can dynamically update your app settings. So if you're just an application developer and you don't care about the infrastructure, then you can just script this out as a last step in your deployment pipeline. For now, I'm just going to update this in my ARM template. So here I have a Logic app template. In my Logic app template, I define a couple of the pieces that I talked through earlier. So I define the workflow standard plan, I define the Logic app, and the storage account. And that is all that this particular template is building for me. Now I've already scrolled down here and I've got all those different pieces that I just mentioned. I'm going to go ahead and add a new parameter here. So I'm going to copy my new parameter. Now this is where it gets cool. And this is something that I particularly found quite nice. And that's because, before I pasted in my whole connection string to that service bus service. Now, as a developer in local development, in local settings.json, you usually have a couple of developer keys. But when you're deploying out to Azure, you don't really want those live keys in any type of form that, someone can take advantage of them. So this is where we can take advantage of the app settings ability to call out to Key Vault. So as you can see, I'm calling out to a Key Vault instance on Azure, and I've got my actual production service bus string in there. So I never have to see it as a developer, or my pipeline never sees it either. So that just gets defined there. I would give that a save, and that's all I need to do. So I've created my new service bus connection in my workflow.json. I've copied all the different parameters that I need to different parameter files so that if I need to deploy it to different environments, I can change it there. And I've made sure that my app settings are propagated into my Logic app resource. So that's all you have to do to create a new built-in connection. So now let's go ahead and push this up and talk through the pipelines that will go and deploy this. So in this case, I'm going to just check through my changes. I've added a new app setting. I've pasted in my parameters. I've configured a new connections.json file. I have another new parameter file, and there's my new action. There we go. So new service bus connection. Okay, I'm going to hit deploy, and I'm just going to zoom around because my laptop's in the way. And there we go. I'm going to push that up to my Azure Devops instance. So let's flick across to that. All right, so here are all three of those pipelines that I mentioned earlier. Now I do have these defined in YAML, so I can develop these locally in VS Code, but I'll just go through them here because everyone likes a GUI. So if I go and refresh that, you'll see that those new changes have been pushed and my new CI pipeline will be building. This is super quick because it's actually not doing a whole lot. So let's dive in. I'm going to go ahead and edit this. Alrighty. Okay, so this is my build pipeline. I'm going to zoom in a little bit just in case. And I usually prefer the actual GUI version of this in pipelines, but YAML's just so convenient to use. So I'm going to demo in YAML today, and that is the sample pipelines that are available in the sample repo. So all this is doing, in a nutshell, it's just doing a couple of different lines of code. It's copying the files to an output folder. It's just zipping those files. It's not doing any specific build action. It's not doing anything .NET focused or Java based. It's just zipping a bunch of files up, because at the end of the day, it's just a bunch of configuration files. Once you've zipped this up, it then deploys it out into a deployment file. Zip drop folder in your Azure Devops repository, which your continuous release pipeline will go pick up and then plop onto your Logic app. Now, there's a whole bunch of things you can do in here. You can configure tests, you can configure anything to actually validate those Logic apps, but this is a very simple pipeline, so it's just going to copy those files, zip it up, and then pass it along to my continuous release. So if I come back to all my pipelines now.
One quick question before you go on. Mm-hmm. Is there any way to run a test against the Logic app in the build?
In the build itself, there's no, right now, and I'll say right now, there's no bespoke tools to do that. You can configure different scans and different ways.
It's the same thing we've run into with functions. Because like if you have an API app that's written in code and you run the build and you've got a executable, you can actually launch that executable and do some tests against it. Where with functions and things that run in those containers on your local machine, there's no way to really run unit tests in the build at the moment.
Yeah, I would say it's the same for functions, same with Logic apps as well. You would have to host it somehow to be able to run unit tests against it.
Okay.
Yeah. But good feedback. I'll talk to you offline in terms of what you like to see for that, because I think that's a good use case.
Yeah, that was a question from one of my ex-BizTalk friends that when they were moving some stuff over.
Yeah, good call out. So my C continuous release pipeline has just run as well. So I'll go through what that is doing. Let me go ahead and edit this. Oops. So just to recap, my CI pipeline is just taking the files, packaging them up into a zip, and then this particular pipeline, it's going to run continuously after that, download the zip file that I had published. And the only action that it's doing here is it's reusing the Azure function deploy action and passing that to my Logic app. In my actual project itself, I have a variables file, which I define the names for everything. So that's how everything kind of gets passed along. But that's the only action. So really, the CI, the build, is just zipping up the files, and the deploy is just reusing the Azure Functions action to deploy that to your Logic app resource. On the roadmap, I'll talk a little bit later, we will be creating our own Logic Apps task and Logic Apps GitHub action to simplify a couple of the steps for Logic Apps specifically. But that's essentially it. That won't change between whether you have API connections or built-in connections or functions connections. That is the way, or one way, a very simple way of building your Logic app and deploying it out to your resource. And that runs super quickly. So the application side of things can run at a much faster cadence than your infrastructure pieces might run. So let's go ahead and look at that Logic app that we deployed. If we jump in here, we'll be able to see our workflows that we've just been developing locally. So So here we can see my event trigger and my event processor one. So we changed event processor. Let's come and dive in there. Let's go to designer. And if I didn't accidentally copy in the wrong key, we should see that that has all propagated correctly and everything is working smoothly. There we go. So that connection, it's all working well. It's all passing through those parameters, those app settings. That's all well and good. If I go ahead and run this, which I can now do in the portal with run trigger and run with payload, I'm just going to go ahead and run that. I did bulk load a couple of messages in before, so that might be why it's failing. So let's have a look.
Quick question while we're looking at this. I know with when you deploy a function and you deploy it from code, it is read-only in the portal.
Yep.
But I noticed that it looks like the designer, even though you've deployed it through a DevOps pipeline, that you still can edit in the designer.
Yes. I just want to see what this says. Okay. I pasted in the wrong connection string. That is why it didn't work. But anyways, if I'd pasted in the right one, this would all be working quite seamlessly. Yeah, so there is a read-only mode that we do have configured, but that's only when you deploy to Arc-enabled Kubernetes clusters and with containers as well. So it is something that we have, and I believe there is a way of turning that on. I would just need to find the relevant parameter to pass through. But we do have that configured. It's just a case of enforcing it and whether we should, because Logic Apps is, we know people love to develop in the portal, and turning that off would kind of cut off a lot of the scenarios that places that people like to develop their Logic Apps.
Yeah. So my big concern is the dev instance of it. It's fine for them to edit, but for test and production, or for like UAT and production, I probably don't want them editing in the production space. I want them to go through the normal DevOps deployment pipelines.
Yeah. We can take that one offline. There are ways that you could do that. It would be with role-based access control and access policies and stuff like that. But
it's just it was one of the early questions that they got with the functions.
Yeah,
because they had the same issue kind of with functions when they first put them out. I got a couple of companies saying, but I don't want people to be able to edit in the portal. I want them to go through my deployment process with approvals.
Yeah. Good call. I don't have a seamless answer for you yet, but I can say that it is coming, and we do have that functionality. It's just a case of turning it on. Alrighty, so reviewing what we've done, we have built a new built-in action, and we've pushed it up, and once our developer doesn't make a silly mistake like putting in the wrong connection string, it's all working well. So now let's go ahead and create like one of those API connectors that are hosted as separate resources. So this kind of blends the world of the infrastructure and the workflow development, because those API connections are separate resources. We have to think about, how we represent them in our ARM templates and what they look like in different environments. So now I'm going to come into my event trigger, and I'm going to reconfigure a new trigger. So in this case, I just have a very simple reoccurrence calling a child workflow. I'm going to delete that and create a net new connection. So I'm going to use one of the Azure connections. So I'm going to use the blob one. We also have this as a built-in one, but just for demo purposes, I'm going to show how we can build the blob as a separate Azure resource. Okay, so the trigger will be when a blob is added or modified. And I'm already connected up to my resource group. So the connection is there, but the connection metadata is not there yet. So I'm going to choose the storage account, choose the container. So whenever a new blob enters this container, this will trigger my workflow. I'm going to restrict it to just returning 1, and I'm going to make this check every 15 seconds. All good. So once that's saved, I'm going to flick across into my connections.json file. And as you can see, the managed connection looks a lot different to the service provider connection, which is the built-in connection, which kind of goes to that point of, built-in connections are a lot easier to DevOps because they're built in, they're as part of that build artifacts, and they automatically are parameterized for you. We are working on automatically parameterizing this as well, so you don't have to do this all manually yourself. But there are ways to completely parameterize this out so that this file remains static, and the only things that change are your parameter files or your app settings. So I'm going to paste in what a parameterized version of this will look like. Paste it in just to save some time. Okay, so this looks a little bit different. So what I've done here is parameterize some of those different strings that should not be flat, and that actually will change between environments. So for example, my subscription ID might change between environments. I might change between a prod subscription and a test subscription. So I need to parameterize that out. My workflow location name might change as well if I'm deploying to different regions. So I've parameterized that using app settings. Now, I've used these names because when you actually are locally developing and you choose to use Azure Connections, you already have these in your local settings. So it's really easy to just use those as you go through your development. The same thing for the connection ID. I'm just configuring those things that might change. For example, the resource group name will probably change between environments, so that's been parameterized out. Everything else can remain static. The connection runtime is essentially just a pointer to where that Azure resource lives, and that will definitely change between different environments because each connection per environment will have a different endpoint URL, and the authentication block will change. Now, the reason I've got everything in app settings and only one thing in parameters is that these things are things that I can grab from my infrastructure deployment. They're really easy for me to go and update dynamically as I actually go and create all my infrastructure resources. So it makes sense for me to update them as part of my ARM template deployment. With my authentication block, if we go back to what that looked like earlier, this is actually a complex object, which, as I mentioned before, app settings doesn't do so well in. So this is where I can take advantage of parameters to hold that complex object, because at the end of the day, this is going to change a lot when I migrate or when I deploy this to Azure. Rather than using a raw key, it's actually going to be using a managed identity for authentication. So I'm going to go ahead and save that. And then I'm going to update my parameter files with those different complex objects. So here in my parameters file, I'm just going to add it. Essentially, I would copy this from my connections file, paste it in here. And I'm going to do the same for Azure, except it's going to look a little bit differently. And we've got this documented on our DevOps documentation. But essentially, rather than having a raw key to authenticate against, we're using the managed identity. The reason that VS Code has a raw key is because you can't associate a managed identity with something that's running locally. It has to be running on Azure. So that's why that particular authentication block changes between environments. So there you go. I'm going to go ahead and save this. I'm going to walk through what we would need to do as an infrastructure specialist to actually configure that connection. I'm going to breeze through this because I'm aware of time and I want to make room for questions. But here I've got all of my infrastructure templates again. I have a separate template for my connections, so I can kind of use them and deploy them separately. In here, I'm just creating a storage account dynamically for that blob connector. I'm creating that blob container. And here I am defining that connection here. Now, there's a bunch of different ways we can get the schema for this, because I know that there's a very commonly asked question, and I have a bit of a very sneaky workaround around to do that, because I know that this gets asked a lot. We do publish what the main schema is in terms of name, location, kind, the main properties, but in terms of what I need for the parameters value, this is what will change between connections. So this is just a cheat way to grab that. So all you need to do, go to any Azure resource, go to the designer, create the same connector that you want. So in this case, I'm creating a Logic Apps connector, a storage connection. I'll wait for that to load. Melbourne's just gone on lockdown, so I assume that everyone's kind of hitting Netflix or looking at the news. This is why my internet's a little bit slow. There we go. So I'm going to go ahead and create a new connection. Let's create a blob one, as I did before. I can create any old action here, it doesn't really matter. And I can actually just put in a bunch of gibberish here. Oh, wait, sorry, change connection, add new. So I'm going to add a new connection. Wait for this to load. And while that loads, I'm going to open up my developer tools. There we go. So pop a bunch of gibberish in. I want to authenticate via access key. Gibberish, all good. I'm going to hit create. It's not going to be able to create it for me. So I'm going to go and find this one. No, this one. Yes. If I go to the networking tab, once I go into my developer tools, it's a very workaroundy way, but I find it's just a bit of a hack to find it really easily. If I scroll down to the bottom, I can see the request payload that the engine made to go and create that resource. And if I go into this properties particular area, I can see what I need in parameters. So here I can see I need an access key with a value and I need an account name. Now, if I go and see all those different properties here, this looks very similar to what I need in my ARM template. So that's just a really simple way of getting what needs to go into those parameter bag for your ARM templates. It's a bit of a hack, and we are working on ways to make that easier and seamless for you. We are working on a CLI for connections, which will be coming soon. But that's just in the interim. If you need to be able to easily get the ARM template definition, that's a bit of a hack. So yeah.
I actually found the proper way to do it.
There is a proper way to do it, yes.
There is a management API that you can call for each one of those managed connectors that will give you all of their parameters.
Yes, we can go through that in a separate one, and I have that documented online in our docs.
Yep. Yeah, I found it this last week when I was doing some Edifact stuff. I needed to create the Edifact ARM template, and trying to find the values was impossible because nobody actually put them out there.
So 2 hacks that you can use. The last thing you'll need in your ARM template is the access policy. As mentioned, that's just giving your Logic App identity the ability to actually use that connection. And that's it, as well as like the service bus or the built-in connection, you'll also need to update your app settings with anything that you have called out in your connections.json. So here I called out my workflow subscription, location name, resource group name, and something that I'm going to dynamically update in my pipelines. So in my infrastructure as code pipelines, if I come here, there's my infrastructure pipeline. I'm not going to go through this bit by bit. It's the same as any other infrastructure deployment. I just have the one environment dev, which calls out this particular file. This is, first of all, deploying my Logic App resources, which is my Logic App, my storage account, and my workflow plan. And then it's going to deploy my connectors. I can deploy my connectors to a different resource group if I want. The benefit of doing this is that if you have anything like Office 365 or Teams or Salesforce that does enforce a manual sign-on every time you redeploy, having these deployed to a separate resource group means that you can separate them out and you don't have to deploy to them as frequently, which is nice so that you don't have to manually re-authenticate every time. And then I'm dynamically updating those app settings. A whole bunch of stuff that will run successfully. It'll deploy all that stuff from where to go. Don't have time to go through everything, but that is essentially the end-to-end view of that. If you do want to get your hands on that baseline template, we have that in samples, so you can use it as a baseline to help you get started really quickly. I won't go through those steps, but I'll put that in the documentation on those repos so that you can get started like I have here. And then a very quick word on our roadmap before passing over to questions. The parameters UI that I showed, that is going live very soon. And so looking forward to your feedback on that. We have a bunch of CLI improvements that we are planning in development at the moment for both workflows and connections. So that will be a really nice addition, especially for those who prefer scripting. We are building out the GitHub Actions and the Azure Devops tasks, so you don't have to reuse the Azure Functions action. And automated testing tools are something that we are looking and designing out at the moment. So if you have any feedback, if you have anything you'd like to see specifically with automated testing, we'll have a chat. Have your say at the feedback form or just get in touch and we can have a chat. So yes, that is breezing through all the content. I can talk for hours on this topic, but if there are any questions, I'm happy to address them.
There's no questions out there at the moment, but if anybody wants to post a question. The other question I had was, I know that a couple of weeks ago that the standard designer started showing up for some of the consumption-based Logic apps.
Mm-hmm.
And then now it's gone again. Any update on when that might show back up?
We're doing A/B testing and slow rollout. So if you saw it, you're probably one of the lucky few of you got to go be in the A grouping. And we're slowly rolling that out over time. So eventually the new designer will be available for consumption.
Very good. Let me just add the other guys in.
Thanks, Bill.
So,
thanks, Bec.
That was that was really good. The using the app settings from inside of that parameter file, even to get to those connection settings, that looks really good. That's going to be something that definitely have to look at. Because what I was doing is actually you can use. There's a couple of tools that we found when we were doing functions on Linux. Because the function deployment on Linux doesn't have a way to update the app settings, but the one for Windows does. So we found a tool that would crack open the zip file, go find your parameters.json and update the values in that, rezip it, and then deploy it.
That sounds hard. I mean, it works.
It works,
and I also find interesting that with that technique, you can actually use when you containerize, you can use environments settings as part of your Docker file, and then it pushes all that information too. So it makes life much easier. I was playing with that as part of my integration session, like on those crazy nights between midnight and 6 a.m. watching integrating, trying to get everything ready for the next day. But yes, it actually helped a lot.
Yep. So yeah, that looks really good. I'm actually I've done a bunch of EDI stuff a couple of weeks ago, and I did it in the consumption because that's where I started. But I think I'm gonna move it all to the standard now, just to help with some of that deployment side of things and to make the designer easy. Because a lot of them, I did a consumption-based project about 9 months ago that had a bunch of helpers, and they were harder to call out to. The helpers are really easy to call out to when it's in standard because they just show up when you click call another Logic app, And
Yeah.
I think that's going to be a lot easier. And it's also cleaner when it's deployed. It's a single logic app deployed instead of 25 logic apps that call each other. So I think that's going to be a lot cleaner approach. The only question I've got is the flat file encoders and decoders.
Yeah, it's coming.
Yeah, because what was it? Dan Provitt was on the call last week or last month.
Yeah,
and he alluded to the fact that there was some BizTalk code in that the flat file decoders that they didn't know how to ship.
Yeah, we're working through that problem because we're updating the BizTalk migration tool to be able to run on standard. And yeah, we're coming across that issue with encoding and decoding. And so we're coming up with workarounds and, talking to Divya on, when we can get that available. But yes, you'll be the first to know when we've got an ETA on that.
Yeah, because some of the EDI work I'm doing's got flat files involved in it that are non-EDI files. So that because you can't even call the one in Azure from the standard.
I haven't tried it out.
It doesn't show up. It's not in built in. It's not in the Azure ones. So it's
because you don't have a logic app to host integration account to then do the thing, right?
It must
So
be.
you don't have the reference on the logic apps. On the standard, you don't have integration account anymore, and you don't have a logic apps on consumption to do the reference to integration account to then call the flat file. So you get like on a chicken and egg situation.
But the EDI works in standard because it sets up a connection to the integration account as a connection. So you can do Edifact and AS2 and X12 from standard because it calls out to the Azure ones, and it creates a connection object in there that's a managed connection for the integration account. So
yeah, I'm on my wife's computer because my one was like that's why I was late for the meeting. So I don't even have Visual Studio Code to try to test it while we're talking.
We have a question. Function app connections is sending key as query string parameter. Can we send in the header? Function app connection is sending key as a query string in the parameter. Can we send it in the header? Okay.
Right now, because I was talking to one of the engineers about this. So we built the schema in connections.json so that we can expand it in the future. From what I understand, that's the only option for right now, but there might be further options for authentication going forward.
Yep. So let's see. Yeah. Yeah, that's yeah. Okay, yeah, we'll follow up on that because I know it's a little bit like API management gives you a choice of having your API key in the header or in the query string, and most people want to put it in the header because of just the fact that it's hidden more. I'll follow up because then I'll get it's Amrit, one of the guys that Dan and I used to work with at Mexia, and I'll get with you, Amrit, to follow up with Bec on that.
Yeah, let me in. Happy to help.
Yep. So I think that's about it at the moment. No other questions are out there. Thank you very much again, Bec, and all of us as MVPs are looking forward to catching up with you once you get to Redmond, and once we ever get back to Redmond.
That's true.
I'm afraid I'm not even going to be able to get there because everything in Australia is locked down. I'm not even going to be able to move.
Yeah, I know. It's going to be one of those things. So, but yeah, it's because I got a wedding invite from one of my rellies for a wedding in August, and I'm going, yeah, I don't think I'm going to make that one.
Yeah. I know
So-
some friends, they were meant to have their wedding on the weekend in Melbourne, but they last minute moved it to tonight. I can't imagine the stress of moving a whole wedding.
Yep, that would be a little bit of a challenge. So I know they were talking one couple a couple of weeks ago on the project that had moved their wedding 3 times now. So
Oh, no.
I think I think that would just kind of justice of the peace it, and then figure out when we can have a party to go with it.
My poor family friend has rescheduled her 21st. Like, her 21st was in March last year, and she just has the worst timing. Every time she's rescheduled it, there's been a lockdown, so she's had to reschedule it.
Tell her not to reschedule it. She's causing the lockdowns. No.
Yeah,
just go to an impromptu. Yeah,
Yep.
send a WhatsApp message to everyone. Let's go tonight.
Yeah, we've got a few more comments. Amrit said, "Hey to Dan," and then Brian Porter said, "Thanks to Bec, very informative." So
Awesome.
again,
Yes,
if anybody has colleagues, this will be up on our YouTube channel tonight as soon as we finish. I'll put it in the playlist so it shows up in Integration Down Under. Thanks again, Bec, and look forward to hearing you give us a talk next time from Redmond. So
I might still be interested. We'll see. But thank you.
In the broadcast now, and I will talk to you guys later.
Awesome.
Thank you, everyone. Thanks, Bec. See you guys later.